In this example, we are going to look at integration by recognition, where the integrals consist of two parts. The first part is actually the derivative of the second part. The second part is normally to the power of n. If that is the case, your integral will be equals to fx to the power of n plus 1 divided by n plus 1, and of course plus the constant c. Now we're going to look at two questions simultaneously. And if you look at this one, that's 2x, and then 3 plus x squared, whole thing to the power of 4 dx. And this is x, square root of 3x squared minus 1 dx. Let's look at both in the format that we are familiar with, where you notice that in this case, I've changed the square root to the power of half. Now, if we look carefully, we notice that 2x is actually the derivative of 3 plus x squared, which is consistent with this. However, in this case, x is sort of the derivative of this. However, the derivative of this should be actually 6x. So if that's the case, if I want to keep a 6 there, I should actually add a 1 over 6 here. So let's see what we could do if I rearrange it slightly. So I have 6 and I have 1 over 6. Now this is now okay, where this is actually the derivative of the bracket. When we are in this position, we can then utilize this formula, where basically what I need to do is just take the power and then add 1 and divide it by the power at 1. In this case, our answer is 3 plus x squared to the power of 5 divided by 5. And over here, 1 over 6 is still there. 3x squared minus 1, now it's to the power of 3 over 2, because that is from half plus 1. Similarly, now I have to divide by 3 over 2. Rearranging the equation neatly, I will get 3x squared minus 1 to the power of 3 over 2 over 9 plus c. So there you go. Two examples where you can solve by recognition without having to go through the tedious steps of substitution.